Math!
Hello everybody, this is Mr. Regener, and this is our focus review for week 19, day 3. So let's go ahead and get started with number 1. Now number 1 says a parallelogram has a perimeter of 30 inches. The length of one of its sides is 10 inches. What are the lengths in inches of its 3 other sides? So in order to answer this question, we really want to understand first, what is a parallelogram? A parallelogram is a shape, has 4 sides, and 2 of the sides are parallel. So 2 sets of parallel lines. Parallel lines, remember, are lines that go on and on forever and never touch. So these 2 lines, assuming I drew them straight, will never touch. And then these 2 lines will go on and on and on, and assuming I drew them straight, will never touch. Now we know that the perimeter of the whole thing is 30 inches, and perimeter is the measurement of the outside of the shape. We also know that one of the lengths of its sides is 10 inches. So I'm just going to label like this side 10. Now if I know that this side is 10, and this is a parallelogram, then this opposite side has to be 10. So I labeled the bottom and top as 10. I could have easily labeled the side and the side as 10, but I chose top and bottom just because it was random. Now I want to look at my multiple choice options because I know that 10 is going to be my second side. So here I have 3, 3, and 5. There's no 10 there. So it can't be A. 5, 5, and 20. There's no 10 there. So it can't be B. Man, I am like already in great shape because I'm down to 2 options. So now I want to think, if the total is 30, 10 plus 10 is 20. That's going to be 20. That means that the other 2 sides have to make up for the remainder, whatever is going to get me to 30. So 30 minus 20 means that I have 10 more to go. So my other 2 sides have to add up and equal 10. Another way to look at this is I could take 10 plus an unknown number, let's call it x, plus x equals 30. So I want to figure out then what is my unknown sides, or my x. Now here I have 5 and 5, or 20 and 20. By adding them together, 10 plus 10 plus 5 plus 5 will equal 30. 10 plus 10 plus 20 plus 20 will equal something much bigger. So my answer here is letter C, 10, 5, and 5, because I know that my one side was 10. The other sides have to be 5 each. And that's my work for number 1. Moving on to number 2. Number 2 says you have 54 red apples and 72 green apples. If you use all the apples to make identical fruit baskets, what is the most amount of baskets you can make? So to answer this question, we want to use the greatest common factor. We're really just looking for the GCF. So I'll set up some factor trees for 54 and for 72. So again, your factor tree may look different than my factor tree. In the end, we only care about getting the right prime factorization, so I might have different numbers in the tree. So 54, maybe I'll do 9 times 6. And then 9, I'll do 3 times 3, and 6, I'll do 2 times 3. All of those are prime numbers. For 72, let's see, maybe I'll do 9 times 8. And then 9, I'll do 3 times 3. And 8, I'll do 2 times 4. And then for 4, I'll do 2 times 2. So now I've made my prime factorization. I want to list them out. So I have 54, which is going to be equal to 2 times 3 times 3 times 3. 2 times 3 times 3 times 3. And then for 72, I have 2 times 2 times 2 times 3 times 3. Okay, now I've listed out my prime factorization. I want to pick the partners. All right, so I'm going to switch up my colors here. I've got a partner here of 2 and 2. I've got a 2, but no 2's up here. Another 2, but no 2's up here. A 3, which I can partner up with a 3 here. And then another 3, which I can partner up here. So in the end, my greatest common factor is going to be one of these 2's multiplied by one of these 3's multiplied by one of these 3's. I can use order of operations and combine them. So 2 times 3 equals 6. And then 6 times 3, that's going to be 18. So my greatest common factor is 18. But to truly label this, I can use the word baskets. So I'll say 18 baskets. And there we go. That's my answer for number 2. Moving along to number 3. Here it is. It says a buoy is 45 feet from the shore. You swim 7/9 of the way to the buoy. How much farther do you still have to swim to reach the buoy? So we want to think about this one as far as how much further do we have to go. We already know that we swam 7/9 of the way. We want to know what's left. For this one, I like to draw a picture. So here's my shoreline. Let's put a little beach umbrella here, right? Maybe like a beach chair waiting for me. That's a really bad beach chair, but you get the idea. And then over here, this is going to be my buoy floating in the water, right? It's got like lines on it or whatever, maybe a little light, whatever it might be. And then in between is going to be my water. Now the thing about this is it says that I'm 7/9 of the way there. So I can literally make like a little line here to show this would be 9/9. So I'll separate this out into ninths. There we go. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 parts to this one whole distance from the shore to the buoy. That whole thing represents 45 feet. Okay, so knowing that this whole thing is 45 feet, right now I am 7/9 of the way there. I'm going to draw myself swimming here. That's 1, 2, 3, 4, 5, 6, 7. So I'm like right here swimming in the water. Okay, so I need to go from here all the way over here. I want to figure out what is the distance here. So clearly with my drawing, it's kind of easy to see that it's 2/9 more to go. So I need to go 2/9 more. Or if I know it's 7/9, I could simply take 9/9, subtract 7/9, and then I'd figure out that I have 2/9 more to go. So if I know it's 2/9, I want to figure out what is 2/9 of my total 45 feet. To do that, I just need to multiply 2/9 of 45. That's 2/9 times 45. And remember, 45 can become a fraction just by making it over 1. So now I want to think about cross-simplifying with 9 and 45. Luckily, 9 goes into 9 one time, and 9 goes into 45 5 times. That makes my math so much easier. Now I'm looking at 2 times 5, which is 10. I almost wrote something different. I don't know what I was thinking. And then 1 times 1 is 1. That's 10 over 1, which is really just 10. And I can label that as feet left to swim. I am finding the very bottom corner of my smartboard, but I hope you get the idea. So I have 10 feet left to swim. That's what 2/9 would be, 10 feet, according to this problem. Let's move on now to number 4. Number 4 says choose all the expressions that are equivalent to 6 times the sum of m plus 4 minus 4. So to answer this question, I'm just going to rewrite that and then try to simplify it down and then find some of the things that are the same over here. So I have 6 times the sum of m plus 4 minus 4. I'm going to look at this first one first and use the distributive property. So I can distribute my 6 over to my m and to my 4 by multiplying. 6 times m is 6m. Keep the plus sign in the middle. 6 times 4, that would be 24. And then I'll bring down this minus 4. Now I want to look about simplifying even more and look at my like terms. I have 24 and 4. Both of them are regular old numbers. There's no letters attached. They're not coefficients, so I know I can combine them. 24 minus 4 is 20. So I have 6m plus 20. Now if I look over here at my options, I want to be very, very careful and look deeply at all my options. Letter A, 6m plus 10 minus 4. There's no way if I combine 10 minus 4, I get 6. That's 6m plus 6. That's not what I got here. Letter A is out. Letter B, 6m plus 24 minus 24. Well, if I combine 24 minus 24, I'm left with 0. There's no way. Letter C, 6m plus 6. Let me take a look at it. And no, there's no way that 20 is going to become 6. Letter D, 6m plus 20. That's the same thing I got there. So I'm in good shape there. That's letter D. And letter E, 6m plus 24 minus 4. That's exactly what I have here. So letter E, I guess I should circle the whole thing. Letter E is also an answer. So I come up with my answers of D and E. this is our focus for this week. Hopefully this video will help you review in preparation for this week's quiz. I'm Mr. Regener. This has been Focus for week 19, day number 3.
Math, aftermath, it's the aftermath. Aftermath, it's the aftermath. Math class is fun, but when it's done, stay in the zone. On your own, it's math review, made just for you. Take a video wherever you go. Aftermath, it's the aftermath. Aftermath, it's the aftermath. Oh yeah.